Alright, this LeetCode question is called Add Two Numbers. It says you are given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order and each of their nodes contain a single digit. Add the two numbers and return it as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. So for the example they give us, the input is two linked lists, one being 243 and the other one being 564, and the output is 708 because when you add 342 plus 465, you get 807. Alright, let's start by just adding two numbers. If you have 948 and you add 324, what's the result? Well, you'd start all the way at the right and you would add 8 plus 4. 8 plus 4 is 12, so you'd leave the 2 here, and you would carry the 1. Now you would add the digits in the next column. What's 4 plus 2? 4 plus 2 is 6, but we also carried a 1 over, so we'd have to add that to it. So 4 plus 2 plus 1 is 7. Finally, we have 9 plus 3. 9 plus 3 again is 12, so you would leave the 2 here, and you would carry the 1 to this column. Let's just move the plus sign over a little bit. Alright, we know we have no more columns to the left, but we also know that we carried the 1. Because of that, we need one more column to the left, and we would add the 1 to that. Okay, so let's do the same thing again, but in slow motion. So we start again at the right, and we add the number in the top row. We can call that number x. And we add that to the number in the bottom row. We can call that number y. So the first rule we can come up with is we can add x plus y. Alright, so we've added x plus y, which gave us 12. But we know we can't put 12 in this column. We can only put the number 2. How do we go about only getting the number 2? At this point, we'll take a break and talk about the modulo operator. Alright, so let's say we had 4 plus 8. What would that equal? That would obviously equal 12, right? But what if we only wanted what was in this column? What if we only wanted the 2? How would we get that? Well, there's an operator called the modulo. And the modulo looks like this. It looks like a percent symbol. And all the modulo does is it gives you the remainder after one number is divided by another. For addition like this, we know that to get the number in this column, we add up these two numbers, right? And if these two numbers are less than 10, the number in our column would just be the sum of those two numbers. But if it's above 10, we only keep the remainder above 10, right? Meaning 4 plus 8 equals 12. That's 2 above 10. Well, we can use the modulo operator for that. In this case, we have the number 12. We use the modulo operator on it, and that would give us a remainder of 2. This 2 is the same as this 2. Let's say we had 4 plus 7. 4 plus 7 is 11. To get this one, again, we take our total, modulo 10, and that would give us 1. And again, this one is the same as this one. But what if the two numbers added up to less than 10? In this case, we have 4 plus 3. 4 plus 3, as we know, is 7. How would we get that 7? Well, the modulo operator works for this too. So we just do 7 modulo 10, and that would give us 7. Okay, now we know we can use the modulo operator to do this. So our second rule is that we take our total and we do modulo 10, and that would give us the number we need. Okay, so we've gone through our first two rules. We added x plus y, so 8 plus 4, which gave us 12. Then we do 12 modulo 10, which would give us our number 2. But we know that 8 plus 4 doesn't equal 2, it equals 12. So we've left the 2 in that column, but we know that we have to carry the 1. How do we do that? Instead of using our modulo operator, we can just divide by 10 and round down. So think about it. If a number is greater than 10, let's say 11, when you divide it by 10, you get a number that's greater than 10, right? You would get 1 point something. When you round that down, 1 point whatever, you would get the number 1, which is the number you need for your carry. Okay, so to recap, we've added up our x plus y, so 8 plus 4, which gave us 12. We then took that number 12, and we did 12 modulo 10 to give us the number 2. Then we got our carry by taking that same number 12, dividing it by 10, and rounding down. That gave us the carry of 1. But are we done with our rules yet? Close, but no. And we'll demonstrate that by going to the next column over to the numbers 4 and 2. We'll go through our rules so far, so let's start at the beginning. What's x plus y? In this case, our x is 4 and our y is 2. 4 plus 2 is 6. We do 6 modulo 10. That would be 6. And then to see if there is a carry, we would do 6 divided by 10 and round it down. That would give us 0, so there is no carry. But there's a glaring mistake. This column shouldn't add up to 6, it should add up to 7 because we carried 1 over from the previous column. We just have to modify our first rule. We don't just have to add x plus y, we have to add x plus y plus the number we carried over. So let's rewind and instead follow our new steps. The first step is we add our x plus y plus carry. So what's 4 plus 2 plus our carry 1? That would be 7. Then we do 7 modulo 10. That would still leave us with 7. Then we take that same 7 and we divide it by 10 and round it down. 7 divided by 10 is less than 10. If you round that down, that would give you 0, which is our carry. I could write that up here, but that's taking up too much space, so I'll just remove it. Alright, so now we're at the furthest column to the left, and we'll go through our rules. So what's our x plus y plus carry? That would be 9 plus 3 plus 0. That would be 12. Now we take that 12 and do 12 modulo 10. 12 modulo 10 is 2. Now we take that same 12, divide it by 10 and round it down. 12 divided by 10 is 1 point something. 1 point something rounded down is 1. That gives us our carry. Alright, so now we've gone through all of the columns that we previously had. We just have one more obstacle, which is that we have a carry of 1, but we have no more columns. How do we usually handle this when we add? When all said and done, if we have a carry, we just add the carry to the beginning. Alright, so these are the same numbers that we're using before, except backwards. So before we had 948 plus 324, which gave us 1272. To do that, we went from right to left. In this case, we have our 948 plus our 324, and that would result in the same 1272, but in this case, we'll go from left to right. So the completely sped up, no detailed version of how we're going to do this is this. We'll create another linked list with a head that has any value, so let's say 0, and then we'll just follow the rules that we've created so far in order to fill in this linked list. So rule number 1, x plus y plus carry, that would be 8 plus 4 with no carry so far. That would give us 12. 12 modulo 10 would give us 2. And that has a carry of 1. So we'd add another node to our linked list. X plus y plus carry gives us 4 plus 2 plus a carry of 1, which is 7. That has a carry of 0. Add another node to the linked list. X plus y plus carry gives us 12. 12 modulo 10 would give us our 2. We have a carry of 1. And since we have a carry of 1, we would just add one more node to the linked list with a value of 1. Then at the very end, we would just return our linked list, starting from only here, which would in effect leave us with this linked list. Again, going from right to left, that would give us a total of 1272. All right, but how are we actually going to do this? This is the very slowed down version. Like I just mentioned, the first thing we have to do is create a dummy head. So this will represent the dummy head, and we'll just call it dummy. Now we need to somehow build out our answer from this dummy head. And to do that, we'll use 3 pointers. Pointer 1 will start off at the head of the first linked list. Pointer 2 will start out at the head of the second linked list. And pointer 3 we'll call current. That one will start out at the dummy head. We also need an initial value for our carry since we haven't carried anything over yet. So we'll say carry is 0. Now it's almost as easy as following our rules. Our first rule says that our total is x plus y plus carry. Our x is 8, our y is 4, and our carry is 0, so our total would be 12. Our next rule says to take 12 and do 12 modulo 10. 12 modulo 10 is 2. What we'll say is to take our current node and make its next value that value being 2. Now we just have to see what our carry is, so we'll take our total, which is 12, divide that by 10, that would give us 1 point something, and round that down. That would give us our carry of 1. Now we just have to move our pointers up 1 so we can do that again. So we'll take current and make it whatever current's next property is. We'll do the same thing for P1 and P2. All right, so now it's as easy as just following our rules again. What's x plus y plus carry? That would be 4 plus 2 plus our carry of 1, which would be 7. In order to get the value of the next node in our linked list, we would do 7 modulo 10. That would give us 7. So we'd need to create a new node in our linked list with the value of 7. So we'll say current's next property now equals 7. Now we need to find our carry. What's 7 divided by 10 rounded down? That would be 0, so there is no carry that time. Move up our pointers again. Follow our rules. So what's x plus y plus carry? That's 9 plus 3 plus 0, which gives us 12. Then you do 12 modulo 10. That would give us 2. Set the next property of our current node to be that value, so to be 2. Is there a carry? Yes, because 12 divided by 10 rounded down would give us 1. So update our carry to 1. Then we just reset our pointers. Except if you look, our top 2 pointers, so P1 and P2, have nowhere to go. So in this case, we'll just leave them where they are. Okay, so since neither of our top 2 pointers can go anywhere, our result linked list is almost done, except we still have a carry. And like we said before, if we have a carry at the end, all we're going to do is add one more node with the value of 1. Since we're done building our result linked list, all there's left to do is to return the next property of dummy. Dummy's next property is pointing to the node with the value of 2, so when you return that, you in essence just return this linked list, which is our answer. All right, what LeetCode has given us is a function called add2numbers, which accepts 2 linked lists. What we need to do is add up the values of the nodes of these linked lists and return a third linked list, which represents that sum. I've switched up the example a little bit on the left to add up 64 and 8. All right, so the first thing we have to do is to create our new linked list. And we'll call the first node in this linked list dummy head. So we'll say let dummy head equal a new list node, and we'll just instantiate it with the value 0. It could be any value, but I just picked 0. Next, we need 2 pointers, one for the head of the first linked list and one for the head of the second linked list. So we'll say let P1 equal L1, and we'll say let p2 equal L2. That would look like this. And this would be our result linked list with an initial value of 0. We'll call it dummy. Now we need a third pointer so we can iterate through our result linked list. So we'll say let current equal dummy head. That would look like this. And then we need to keep track of what our carry is. So we'll say let carry equal 0. All right, so now we need to loop through our linked lists and add up the values. And for that, we'll use a while loop. So we'll say while p1 doesn't equal null, or p2 doesn't equal null. Meaning if either of our linked lists has a next node, then we'll keep iterating. Now we need our value for x and y. So we'll say let x equal, and we need to check whether our first pointer is on a node. If it's on a node, then we'll just make x equal to the value of that node. But if it's not, we'll just make x 0 so that we can add the other pointer's value to 0. So x will equal, we'll check if p1 doesn't equal null. If it does, meaning it's on a node, then x will be the value of that node. Otherwise, x will just be 0. We'll do the same for y. So let y equal, if p2 doesn't equal null, then the value of y will be p2.val. If not, the value will be 0. Okay, so now we need our total. So we'll say let sum equal x plus y plus carry. So right now x is 4, y is 8, and our carry is 0. Let me just add the carry variable down here. So yeah, we know that our sum would be x plus y plus carry, which is 4 plus 8 plus 0, which is 12. Now we need to reset our carry for the next iteration. So we'll say carry equals math.floor of sum divided by 10. All right, so now that we have these, we can add a new node to our result linked list. So we'll say current.next equals a new list node with the value of sum mod 10. That would look like this. There'd be a new node linked to it with a value of 2. Then we just reassign current to current.next for the next loop. And that would be this. Finally, in this loop, we just need to advance pointer 1 and pointer 2. So we'll say if p1 doesn't equal null, p1 equals p1.next. Same for pointer 2. So if p2 doesn't equal null, then p2 equals p2.next. At this point, neither of them equals null, so we'll just advance both of them. Let me just fill in the final values of null to make it more obvious what's going on. And I forgot to update our carry from last time, so let me just update that real quick. Okay, so now the loop starts over. We need our x, y, and sum. So our x would be whatever pointer 1 is pointing to, which is the number 6. And our y would be the value that pointer 2 is pointing to, but since it's null, our y would be 0. So then our sum would be x plus y plus carry, which is 6 plus 0 plus 1, which is 7. Now we need to figure out our carry. Our carry would be 0, so we'll just change that to 0. And now we can add a new node to our result linked list. Its value will be 7. That would look like this. And then we just reassign current to the new node. So current equals current.next. Now we can reassign our other 2 pointers. So p1 will be reassigned to null, and p2 won't move because it's already on null. Okay, so our next while loop starts, but since both of our pointers are on null, we actually break out of the while loop. In this case, there is no final carry, but just in case there were, we need to add an if statement. So if carry is greater than 0, we would need to add a new node. So current.next equals a new list node with the value of 1. All right, so all there's left to do is to return dummy head.next. Dummy head's next property is this node right here. So in effect, you would be returning this. All right, let's run the code, see how we did. Looks good. Let's submit. All right, so our code was faster than about 38% of other JavaScript submissions. As usual, the code and written explanation are linked down below. If you're interested in other algorithm resources, those are also in the description below. See you next time.